In this video, we're going to go over some relationships with similar polygons and then use that information to answer a few questions. Okay, so from the first semester, when we looked at congruent triangles, if you're given this figure and told that the two triangles are congruent, we essentially had 6 things that were true. We had all 3 angles were congruent to their respective angles. So that's A with D, B with E, and then finally C with angle F, right? And we also had the same thing for the side lengths. So side length AB was congruent to DE, BC congruent to EF, and finally AC congruent to DF. Okay, so that was from the first semester. Now, with this understanding with similar figures or similar polygons, you'll notice the symbol is different, okay? And the things that are the same are the actual angles are congruent. So angle G is still congruent to angle J, angle H is still congruent to angle K, and finally angle I is still congruent to angle L, right? So that is still true. But what's different is instead of the side lengths being congruent, now they're going to have a proportionality or like a ratio that's going to be the relationship with them. So we would have, let's do GH, and remember ratio is a fraction, so GH over JK, HI over KL, and finally GI over JL. This would all be, all of these fractions would end up being the same, right, to some ratio. All right, and that's called our similarity ratio. So when you have similar polygons, right, they are going to be similar, right, if and only if they have corresponding angles that are congruent and their corresponding side lengths are proportional, right? So that's how we know if they are similar polygons or not. Now, if they are, right, then you get some of these similarity ratios that we're going to use, all right? So the one that I just did here, right, I'll copy this one. This is your most basic one, and this is going to be called the similarity ratio. And we'll use this here in a moment. Then you have 2 other ones. There's the perimeter ratio, which states that the perimeter, and I'll use these same triangles up here, of triangle GHI over the perimeter of JKL would also need to be that same ratio. All right, and then the area ratio, and this one is just a little bit different. So the area of triangle GHI over the area of triangle JKL. The only difference is you take that similarity ratio that we've been using and it would be squared, right? Which makes sense with area since we're talking about squared units. Okay, so let's use that information to help us with 3 questions. All right, so the first one, we're gonna solve for x given that these 2 triangles are similar triangles, okay? So I'm gonna go ahead and write that GH over MK, right? Those are going to be the ones that correspond to each other. And that's gonna be equal to, looks like HJ and KJ, all right? So I can go ahead and say that that's gonna be equal to, that ratio for HJ over KJ is 10/14. So what I'm gonna do is I'm gonna take this fraction and I'm gonna set it equal to this ratio because those are gonna be expressions with x, all right? And I'm gonna reduce that fraction. All right, so you should always reduce if you can, just because it'll make your algebra a little bit simpler. Especially we've stopped giving you guys calculators since the very first unit, so you want to make it a little easier on yourselves. All right, so reducing that is going to be 5/7, and now we have a proportion that we're going to solve. All right, so to solve proportions, we're going to multiply across the proportion or the ratio. All right, get cross products, and those cross products are going to be equal to each other. So 7 times x plus 5 is equal to 5 times 5x minus 2, all right? So that's gonna be, I'll keep going up here, 7x plus 35 equals 25x minus 10. Moving the 7x to the right side with subtraction, I get 25x minus 7x is 18x. And moving the minus 10 over with addition, I get 45 All right, so x is going to be equal to 45/18. And if you look, both of those numbers can reduce, right? It can be divided by 9. 9 times 5 is 45, and 9 times 2 is 18. So you could leave it as 5/2, or if you'd like, you could write 2.5 since we're done with the question. All right, so x is 2.5. Let's do number 2. Number 2 tells us that these two triangles are similar, right? And it gives us the area of one of them. We need to find the area of the other. So I'm going to use this understanding from the previous page of the area ratio. So I have the area of, we'll do triangle MKJ, because that's the smaller one, over the area of triangle GHJ needs to be equal to the similarity ratio squared, okay? So I'm going to use, in this case, MJ, since I have that side length, which is similar, will be a proportion with GJ. All right, you can always look, and I'll encourage you to do this in class, always make sure you got the order here to help you match up which ones are going to have that proportional relationship. So MJ and GJ match up. So writing those down, that's 2/5. But remember, this is going to be the tricky part here. Because this is area, we're going to be talking about that ratio is squared, okay? So what I'm going to do is I am going to write down the area of triangle MKJ over, we know this area is 28 squared units, and that's going to be equal to 2/5 squared, which is going to be 4/25. All right? So now I'm just going to do my same thing I did in the first question. I have a proportion. I'm going to get cross products. So 25 times, I'm just going to label this question mark. So this right here is my unknown, all right, is equal to 28 times 4. So 30 times 4 is 120. Take away 8, that's going to be 112. All right, divide both sides by 25. And that will give us the area of triangle MKJ, which is equal to 112 over 25. That doesn't divide nicely, so I'm going to go ahead and use a decimal, which is going to be 4.48 squared units. All right, so that's how we use the area similarity ratio. Okay, let's do the last one, number 3. So it wants us to sketch a triangle that has these measurements. So I'm just going to make a triangle here. All right, so we have 40 units, 54 units, and 66 units. Then we have a similar triangle. Looks like it's going to be a little larger. I'm going to match up with the 40 with the 60. And this can be a little tricky, but if you look at those 40, 60, that's going to reduce to 2/3. And then if you look at 66 and 99, if you would look at that fraction, that would also reduce to 2/3. So I'm going to match up the 99 with the 66. So my length of my third side, which I'll call whatever you want, Z, right? That's going to match up with the 54. So we have 40 over 60, which is equal to 66 over 99, which is equal to 54 over Z. Now I said that all of those ratios are going to be equal to 2/3. Okay, so I'm going to do 54 over Z equals 2/3. I'm going to cross multiply to get 2Z equals 54 times 3. So that's 50 times 3 is 150. 4 times 3 is 12. Add those together, you get 162. So Z is going to be equal to 81 units. All right, so that's using this understanding of similar polygons, similar triangles, and these ratios to help us solve some problems. All right, come see me if you have any questions. Good luck.